Good evening, good morning, and good afternoon, everyone. Depends on where you are from. Welcome to our second Asia Community Singapore Meetup, which is also the first of this year. So now is the Lunar New Year. So I would like to wish you all a happy and healthy Lunar New Year. I'm Chun Lin, the event co-organizer of Asia Community Singapore. I'm currently co-organizing events for Singapore .NET developers community as well. So we currently only have one website for both of the community groups, which is .NET.sg, as you can see here. So you can always reach out to me on Twitter at go_Chunling if you would like to join us as speaker in our future monthly meetups. So without the support from you all, our community cannot grow to today's scale. Last month, we just celebrated our fifth year anniversary of SES and Singapore .NET Developers Community. Yeah! So, our another co-organizer Marvin also shared about this new initiative, which is meant to encourage more of you to join and further grow our community to share about different knowledge, ideas, or even research projects that you have done as hobby projects. In addition, if you are a working professional from the industry, we welcome you to share about your experiences too. Together, we learn better. Alternatively, if you would like to do more codings and you love to build some things, please drop by our community GitHub repository too. Currently, we have some projects from desktop app to form recognizer to PowerShell. Or if you have some projects that you would like to share with the rest of the community, you can always submit them to our GitHub. As long as you do a valuable contribution to our GitHub, we will always add you as our GitHub member and you can enjoy our .NET Developers Community Singapore badge appearing on your GitHub profile. Not bad, right? So in our communities, we welcome all sorts of meetups. Some recommendations are listed here, including an online meetup like what we are doing now. So this is our second YouTube live session. It's our second online live streaming meetup after the success from our first try with YouTube meetup last year. So thank you very much for your support. Now, in order to keep things running smoothly in our YouTube session, please remember to guard your privacy and abide YouTube community guidelines. Feel free to ask questions in the chat and speakers will answer them after their sharing session. Finally, please subscribe to our YouTube channel so that in the future, you can always get updated with our new videos and upcoming online meetups. Thank you again in advance for your support. Today, we have two speakers. The first one that I would like to introduce is Eng Teong. He is a Microsoft Most Valuable Professional or MVP in Singapore. He is also an evergreen speaker in our communities. For those who have been with us for the last 5 years, Eng Teong should be a familiar name to you. Today, Eng Teong will share with us on how to manage technical debt with Azure DevOps. To some of us who are in software engineering or other relevant industries, the term technical debt should be a nightmare. In this session, we will get to learn from Eng Teong, who will share with us on how we can utilize some of the tools such as Azure DevOps and SonarCloud to help us dealing with technical debts. Last week, Elasticsearch on Kubernetes is moving out of beta and into general availability. So now with ECK, users can enjoy a seamless way of deploying, managing, and operating the Elastic Stack on Kubernetes. In this session, Priyanka will show us how to build a document search engine to crawl document text with search as we type, as well as to integrate NLP and more with ELK stack. Basically, ELK means Elasticsearch, Logstash, and Kibana. And she will also talk about Nest API for .NET, which is the one of the official .NET client for Elasticsearch. So without further ado, I think Priyanka will start first. Let me change the mic to her.
Yes, yeah, sure. Okay, yeah, Chun Lin, thank you for all your introduction, and that was a very succinct way of describing the topics today. And good afternoon, good morning, good evening to whoever is joining this live session. So let me share my desktop and we jump into the topic right away. Okay, yep, and let's begin. So, So the topic for today is actually two very important and highly trending topics, which are squeezed into 40 odd minutes. So please feel free to interrupt me or put your questions on the chat so that we could uh, get through them and reply to your queries. So we will see two things: Elastic Power Document Search Engine and a few things about me. So, I work as a head of innovation technology at an investment firm, especially in the emerging markets equities section. And I'm a full stack developer, but mostly we are working on machine learning, data science related activities in my entire department. And I'm also a public speaker for AI and machine learning, especially for Microsoft technology stack. You can find me on Twitter. I'm with the handle Fuzzy Mind One. So agenda for today would be two topics: Elasticsearch and adding machine learning to Elasticsearch, extending the search capabilities with word to vec. Also, please let me know if I am being too fast or inaudible. Please feel free to tag me. Okay, so let us begin with some good news, which is Elastic on Azure. So as Chun Lin mentioned, Elasticsearch has recently extended its support to Azure platform. Earlier, if you see, we had Azure Search, not Elasticsearch. So Azure Search was built on top of Elasticsearch. But the good news right now is in Azure, Singapore region, the Elastic Cloud is now available on Azure. And this is the first Azure region in Asia which have given this offering. So we can give Azure Search a rest for now, which is like phew, because I am really not sure if Azure Search was up to the standards which have been set by Elasticsearch. Elasticsearch, as you know, is no more just a search engine; it's more of a platform right now. Just a bit of background of why we employed Elasticsearch. So we have a lot of documents, call reports, which we call reports in the form of PDFs or doc or docx files. These are basically when the analyst from our company, they go and pay visit to potential investors or brokers or vendors or clients. So they collect an information about the company or the client, and that is what we call as a call report. So they pay a call to the client and they generate a report about the prospects, the market price, why Franklin Templeton should invest, what are the best prospects this company presents in the emerging market scenario. So all these things are documented and they are stored at a central location. So the thing is, you have a lot of data, you have a lot of humongous amount of data, and this has been getting accumulated for years together. But what do you do with it? Like, for example, if you want to sift through the documents, it is virtually impossible, because we have been storing this amount kind of information for maybe a decade or so, and going through those enormous amount of call reports one by one to find some relevant trend or to find one particular keyword is an impossible task. So the current search was, by normal fields, which is like author. So who was the author of the call report? What was the company, the country of the company for which the call report was written, or how many people had attended the meeting with the a particular vendor or client. So these were the fields, limited fields, which are available in database, and only on those fields you could perform the search. So let's say if, for example, you wanted to have a search on particular word, like for example, Tata Chemicals, or maybe you wanted to search all call reports where you had something similar to Tata or Tata Motors or any children company of Tata's, Or what if you wanted to search for a particular term called ESG inside the document text? So just remember that we are not storing the document text in our relational database. So we are just storing the name of the report and the path on the path where the file is actually stored on the hard disk. From there, it is virtually impossible to stream the text data using a relational database and perform a word search. This is where you want to crawl the document text for about 50,000 odd call reports in various formats, PDF or doc or docx or text. And herein the use case for Elasticsearch comes up to the surface. So why choose Elasticsearch? Like, when you do a feasibility study, a POC sort of thing, you have different options. Like, why not Solar? Why not Splunk? Why not Microsoft Azure Search? So why Elasticsearch only? So, I mean, as I already mentioned, that Elasticsearch is no longer just a search engine. It's a platform. So it offers you UI also in the form of Kibana. It offers you logging also in the form of Logstash, and on top of that some heuristics, so you can have timeline analysis, you can have machine learning if you go to the Kibana dashboard and see that. So more on that later. So I mean, ranked as the most popular search engine. And of course, when you look at the companies which are adopting Elasticsearch and the amount of documentation or use cases similar to ours, which was available using Elasticsearch, are quite impressive. So Goldman Sachs, FICO, GitHub, McGraw Hill, New York Times, they are all leveraging on Elasticsearch. YouTube also, for some amount of recommendation sort of a thing, it uses a combination of Elasticsearch and advanced machine learning. And of course, our team members, they had some prior knowledge on Elasticsearch, and we were able to leverage on that. So from this idea, from it's right from its conceptualization, so building the UI and ingesting all the reports into the Elastic engine, performing heuristics on those, and all of that, because of our prior skill set, it took us around 3-4 months to really put it into production. And I'll show you the actual production use case and how we are searching the call reports and how the call report text is being displayed. And the speed is enormous. Like, in less than milliseconds, you are returned absolutely thousands of search results. So it is just imagine like a Google kind of a scenario, Google engine, where you type keywords and you are getting results in milliseconds. So Elasticsearch enables us to achieve the same kind of efficiency. Just a very brief overview about Elasticsearch. I'm very sure that at this point of time, all of us more or less are familiar with the ELK stack. So I'm not going to take a lot of time on this. Just a flying overview. So it's a distributed search analytics engine, and it works with inverted indexing. And the API can be accessed using HTTP and JSON. So which means it is very flexible, can be accessed across a variety of platforms and with a variety of programming languages. And just so that we are not confused, because a lot of people, when we move to Elasticsearch, said, can we move our entire relational database? So our database is Oracle basically. And can you move the entire database to Elasticsearch? No, Elasticsearch is not to be used as a data store. It's not a relational database. It doesn't have any transactions, referential integrity constraints, right? But at the same time, it is a repository, and it is scalable for huge data sizes and mostly suitable for a big data AI kind of projects, where you have a lot of data which has to be streamed, or unstructured data which you can store it at runtime, all those sort of scenarios. So for structured data, or for your day-to-day activities where you want referential integrity transactions, Elasticsearch may not be a very good choice. So depending on your use cases, your circumstances, we choose the right approach. So yeah, so integration into the emerging market equity apps. So what we are doing? So what we are doing is, basically, if you see, we are going to type a keyword. Okay. So let's say we are searching for all call reports or all documents where electric car is a text, right? So the keyword is also an autocomplete. If you start typing electric, it will give you electric car, electric something, unless until it finds the exact match for the word you're trying to search. And you have got a YouTube kind of filtering also, where you can filter by region, sector, and finally your results could be sorted by relevance or the report upload date, that is when the report was uploaded by the analyst, or the meeting date when the actual meeting took place between our company analysts and the targeted vendors. And your search results are like how you would get in Google. So you would get the name of the document and some text where the keyword is highlighted, and few extra words before and after the highlighted keyword, just so that the person who is searching can make something out of in some sense out of the search results. And as with Elasticsearch, the score which is given, so we have not applied any custom heuristics. The score which is returned is the highest number of hits for the keyword found is the call report which is returned first. So let's say if electric car is found 5 times in a call report, that would be our maximum number of hits. That call report would be returned first, followed by the next, and so on. And so yeah, so this is what, so when you type in electric car, you are getting around 2000 odd results and only about 900 milliseconds. So imagine the and that is only with one node, so it's not even a clustered environment, not multi node, just with a single node, and you are getting this efficiency. So what makes Elasticsearch so fast? What is the quality that actually makes it so fast? First of all, when we are feeding the document text, right? Ingesting the document text into Elasticsearch, you have a lot of NLP related transformations which are happening. So there's something called as tokenization, there's something called as stemming, there's something called as language analyzing, and finally there is inverted index. We will go through all these terms. For inverted index, just remember that inverted index is what exactly happens when you look up the dictionary. So for example, I want you to look up in white papers, when you want to look up particular terms, you will not sift through the entire document. In fact, you will go to the bibliography. In the bibliography, you will find out the references. So I'm looking for some scientific name, for example, hibiscus rosa sinensis, which is the scientific name for hibiscus flower. So I'll go down to the bibliography, find out the page number where that was mentioned, and then refer to that page number. That is how I search. I don't go page by page searching for the word which I'm interested in. Inverted index works exactly the same way. So let's discuss the tokenization, pre-processing, stemming in detail. Okay, so there is some sort of pre-processing involved, wherein we just cleanse the documents. So ignore headers or ignore watermarks, images, just take in the text, no, sort of normal cleansing. In tokenization, what happens is, let's say you have a term, emerging market funds are picking up. So you are breaking the sentences into individual tokens. How you do that, it depends on the engrams you specify. For example, you specify bigrams, so it will take words into two. So it will take emerging markets funds are picking up. If you say trigrams, it will take 3 words at a time, so something of that sort. So it will just break the sentences given some delimiter, and it will tokenize them, right? So stemming is borrowing from a natural language processing paradigm, right? And what stemming does is, for example, you may have words which are play, playing, played, go, went, gone. So you have to identify the root of that word, which means anything with relation to went or gone should also be related to go. Essentially, all three of them are the same. So stemming is basically trying to identify the root of your words. So we perform stemming also on the document text. Your analyzers. Analyzers could be stop word analyzer, white space analyzer, pattern analyzer, lowercase analyzer. So say Tata Chemicals starting with a capital T or Tata Chemicals starting with a small t are essentially considered the same. This is what we do with the lowercase analyzer. So we convert all the document text as lowercase. White space analyzer is ignoring the white spaces. Pattern analyzer is where we are matching call reports which have numbers in between them, or combination of letters and numbers together. Those kind of regex, regular expression analyzers. Stop words. So words which are of not of quite a consequence, like off, from, in, about, you might want to exclude them or not store them in as much frequency. So we have those analyzers to strip our sentences and make our sentences less bulky and easier to store. And finally, as I said, inverted index. So this is a very quick overview of how inverted index works. So let's say you have a document where Avengers 4 is the highest grossing movie in 2019. You have a second document which is Captain America is the first Avenger, and you have a third document which says Captain Marvel is a superhero, right? How it is stored. So every term is taken and in the document its position is analyzed. So of course you will do the tokenizing, stemming and everything. Assume that all of that has been done, and that each term is stored with the document and its position. So this is our first document, Avenger is the first position, and so on and so forth. Take the second document, exactly the same thing is being done. Now at the same time, common words between the two documents, as you can see the position. So Avenger is there in document 1 and document 2 at positions 1 and 6 respectively. The third one, Captain Marvel is a superhero. So the term is occurs in all three documents and its position is mentioned here. Same way you are doing for the rest of the words. Now let's say you are searching a particular term, Avenger Captain America. What it is going to do is it will see all the documents and positions and intersect them, and document 2 has all the terms, so which means that is the most probable place where I can find all my three search terms. This is a very juvenile way of explaining how inverted indexing works. Of course it is much more complex, and when you start ingesting documents we can actually see the complexity of how inverted index works. So implementation and integration of Elasticsearch, how we did that. So this is nothing. We have had a coordinator and we had a primary node. There is a replica node which doesn't do much. It is just a backup of our data. So we are not operating in any multi-clustered mode. It is a single cluster with the replica node as a backup in case the primary fails. And we have a web service which is written in .NET. So it's a .NET Web API which leverages the Elastic Nest API. So Elastic Nest API is basically a Elasticsearch interface, search interface exposed for .NET applications. So we use the Nest API for leveraging on Elasticsearch queries, right? And analyzers, as I was saying, we are using lowercase, edge ngram, whitespace, regex pattern analyzer, and the technical specifications are given. So we are using version 6.6. Now, if I'm not wrong, the Elastic version is already 7 plus something, 7.3 if I'm not wrong. And for crawling or for storing document text, which is called as what we call as attachments, we have to define an ingest pipeline in Elasticsearch. So that ingest pipeline is a sort of extra attachment which we have to install in Elasticsearch, and that will ingest in all your document data in base 64 format. So this is what we are doing. So your request goes to the emerging markets equity app. Then using the Nest API, it will hit the Elasticsearch. Elasticsearch will call reports, queries, and stuff, and give back a JSON response. So as we see here, it will give back a JSON response here from Elastic Engine. You get a JSON response, search results delivered back to the client. And as I was saying, we have to encode call reports in a base 64 format. And we are also storing some metadata about the call reports, like if the extension, whether it is doc, docx, PDF, text, and who is the author, what was the date on which this particular call report was ingested, what was the sector, what was the region. So this is some metadata which is not really necessary if you just want to have it as a document search engine, but nevertheless if you want it, we do this. And this is basically when you are searching for a query electric car, your request and response time is there. And as I said, it is in milliseconds. The response time would be in absolute milliseconds, right? So to search for a keyword electric car in call reports, this is how it will look like. And let me show you the real-time performance, a real-time query. So, sorry. Yeah. And so let us start searching for something with respect to China, for example. Right now, as you can see that I am still typing, and it is giving me a list of suggestions even before I complete typing my input. So let's say this is China. Now let me refine my search. As you can see, as I start typing, it will start refining my search, right? So China overseas, as soon as I type my entire keyword, it will keep on defining the search results. Let us see for Tata, right? So Tata head office, Tata Power. Let's type with narrow down with Tata Chemicals. Okay, now let's search Tata Chemicals. Let us click go. And as you can see, these are the search results. So you have about more than 2000 call reports returned in about 0.463 seconds. It's like, so and you can also see the text of the documents here. So this is the document, and it is highlighting the sample text where the hit was found, where the search term was found, and it is also highlighting some unmatching text also. I'll show you how we do that in code, how you return not matching keywords also along with the matching keywords. So we are returning these keywords just for the users to make sense of what they are searching in the document and whether that document is really relevant to them. Again, you may not type only the terms which are suggested in the drop down. Let's say I wanted to search something like ESG, which doesn't have any suggestions. Let's say there's nothing matching in the suggestions, and if I still want to search, it will still return me. So even if there are no suggestions popping up here, because for suggestions we have limited fields on which the search is being run, but still it is a part of the document text, it is going to be still returned to you with the document, with the search term hits and the document itself. And that filter which I was talking of, you can have filters with region, sector, sort by relevance meaning return the documents where the maximum hits are found. So search results with the maximum hits are found. And when you're filtering, so Latin America, is there any? Yeah, so you have ESG in Latin America region. In sectors, do you have let's say in financials, let me search by financial. Yes, you have sector financials. There are few call reports in those. So this is a normal YouTube kind of filtering, and sort by relevance, report upload date, and stuff like that, right? And just to show you the difference, this was our traditional search. So traditional search, it's just like whatever the fields available in the database. So search by company, let's say Tata, but which of the Tata companies will have the ESG related call reports? They could have energy related call reports, they could have real estate related call reports. So that is a bit of an onerous task, going forward without just searching on the standard fields. And this is where we kicked in our Elasticsearch. So the UI, it is made up of JavaScript controls, and basically when you type these keywords, both the suggestions and the Elasticsearch keywords are being returned by the use of Nest API. So to show you the sample code here, yeah. So this is the Elasticsearch, and this is how we are ingesting. This is how we are defining the elastic index, where we are defining the analyzers, we are defining the we are defining the filters, tokenizers, and stuff, right? And this is where we are defining the pipeline to ingest our attachments. The code, if you want, I will upload it on GitHub. I will strip off some of the confidential things which are very specific to my project, and I'll just upload the skeleton of the code so that people who are interested can leverage on the code. And this is how we are using parallel processing. So concurrent back, we are storing all the 50,000 odd reports from our local hard disk, uploading them to the database. And this is the Elastic library. If you see, these are the Elastic queries, and if you will see, we are using a in the references. If you see, this is the Nest, Elasticsearch.net and Nest. So these two are the entities or helpers which will help us to leverage Elasticsearch with C#.net. And these are the queries which are written, which will for filtering, for returning data, for returning the suggestions, the Elastic suggestions. So at least type in minimum three letters and it will pop up the suggestions. And the Nest API is basically just an extension of the query DSL, the query definition language for Elasticsearch. So basically, if you know the DSL for Elasticsearch, this is just an extension. You can easily figure out what is the multi-match it is doing, what are the query, what are the multi-match fields, and highlight functionality is what we are giving here, highlighting the search keywords. So when you are searching for ESG, this is the highlight functionality where it will highlight the hit exact keywords which are searched. Right? I'll upload the code to GitHub for Elastic queries. Let us proceed. Yep. So this is the first part wherein we know, how Elasticsearch will help us to actually search the document text. So this is a big step within itself. But going further, we faced a different issue. For example, what if I don't know the exact keyword which I want to look for? Let's say the analysts, they are wanting to search for declining trends for DRAM demand, but the call reports may not have an exact match for declining trends. What if it may have words such as downward trend or reduced DRAM sales or stuff like that, right? So Elasticsearch can work only till identifying the exact text. So it can still give you documents where you can find the word DRAM. Okay, but how to get the context? Like, I want DRAM in the context of reducing or plummeting sales or negative trends, those sort of connotations. So Elasticsearch up till here was only able to ingest the document text and do other NLP processing on it and return you the search text. But what about giving me synonyms or the context in which the words are being searched? So for those kind of advanced heuristics, we will need to have machine learning. So a strong NLP platform which can predict word embeddings and which has machine learning capability. So the more text you put into it, the more it will learn and the more exact or accurate prediction it will give to you based on your context. And Word2Vec is one such library that was developed by a person, an engineer working with Google. Okay, so what is Word2Vec? Very simply, because Word2Vec itself is a huge topic, and if it generates a decent amount of interest within you guys in this session, please let me know. I'll conduct a detailed session on the internal workings. It's a very interesting library. So it is a tool that creates word embeddings, which means you give it an input text and it will create a vector representation of each word. And basically if you see, if you look at it, it is a neural network with a single layer, right? So you input a word to it, there is a single neural network layer which will learn and it will output. What do you mean by vector representation? So let's say there is a word called success and a word called achieve, or a word called happy and word called content, right? So basically happy and content syntactically or conceptually mean the same thing. So imagine a vector dimension, something like of three. Let's think in three dimensions. So in that dimension, your word happy may be represented by coordinates 002, for example, just for example. Now the word content will also be represented maybe in some similar coordinates. And if you calculate the cosine distance between those two words, happy and content, you will find that they are very close. The cosine distance is almost like cosec of 0. So the angle is 0, which means they are almost coinciding. those words. So this is what word2vec does. It will ingest words. It will take as input a lot of text, and then it will try to derive similarity between words depending on the context, right? This is usually done by sites which are taking in reviews. So Airbnb, when it takes reviews, so people write reviews like, I was unhappy, I was frustrated, this was not good, something like that. So while collecting all these reviews, if you just give a word bad and find all the synonyms, you get all the reviews or all the words which are close to bad. This is what is achieved by word2vec, right? So but also another thing, that you, for word2vec to work successfully, you have to feed it between 100 to 300 dimensions. Like for the industry standard is around 300 dimensions. So the lesser data will still work with about 100 dimensions, but for data running between like more than few gigabytes, let's say the industry standard for a good accurate prediction is around 300 dimensions. Now just imagine how a vector, 300 dimension vector would look like. So this is the power of word2vec and how it will actually derive contextual information. So we will train this neural network to either predict a word from its context, okay, or other way around. So predict the context from the word, right? So there are a lot of training modes for word2vec as well. So there are, as I said, that's a separate topic altogether. So that is a skipgram, and there's a continuous bag of words and all. So if interested, I'll cover these topics in quite detail later on in later sessions. And yeah, so let's say you have a word elk out of one sentence, introduction to elk, and we are trying to predict it with three neurons, right? So this is how a word2vec very conceptually looks like, right? So basically I had given you a sentence. Sorry, I had given you a sentence. I'd given you a sentence, introduction to ELK, and when I give the word introduction to, it should predict the word ELK or something similar to that, right? So this is the hidden layer of neurons, which are assigned some weights depending on how well the neurons are learning and predicting your output. This is a very sample working for word2vec, right? So what we did for a POC, okay, we had some sample queries referring to various search queries on YouTube relating to Elasticsearch. So something like logging solar tuning performance demo, Elasticsearch introduction demo, SOLR versus ELK pros and cons, Logstash text file logging demo. We had around 500 search queries which we indexed into the word2vec. We did not do a lot of pre-processing on that, just split each query by the white space and lowercase it, okay? You could, what we did in Elasticsearch, stemming, tokenization, analyzers and all, we could have done the entire same thing, but we just wanted to see the viability of having word2vec do such kind of contextual and synonym mapping. So that's why we just kept it very simple. Split each text by a query by a white space and just lowercase it, right? So we for POC we are using Python, but then when it is going to production, we are using the word2vec .NET version for this, right? So basically all these search sentences, you're going to break by words and feed it to the word2vec, right? Word2vec, and there are the simplest parameters which you're going to feed them. So the sentences is an array of array. So this is your sentence words which you're feeding, right? Min count tells the word2vec to ignore rare words, which is what we are doing the stop word analyzers like off, in, and all those things. Window gives the context width. So how many surrounding words to consider, how many words before and after to consider. And iteration, so people who are already doing machine learning, you know that iteration. So how many iterations to go through before it can achieve a satisfying accuracy prediction. So iterations, so we specified around 5,000. Mm, could be, for small data, even around so small data of around 100 to 100 sentences, around 500 to 600 iterations are enough, because we actually ended up with overfitting. But anyways, so we had a lot of for a POC, 500 to 600 sentences is a good amount of data, and iterations up to 5000 gave us an accuracy of around 92%, which was decent enough for a proof of concept sort of a setting, right? So now when you want to search a particular word, so let's say vector embedding, WV is the word to vector for a word solar. We trained it with a dimension of around 150, so it will give you a vector of 150 coordinates here for the word solar. So SOLR in a word to vector space has around 150 coordinates, because those are the dimensions we mentioned. So in a 3 dimension, you will have 3 points. So in a 150 dimension, you will have 150 points. So SOLR in a machine learning world, like these numbers, right? And then when you are calculating something like model which is most similar to SOLR, you see Elasticsearch popped up as the output, because the distance, this is the cosine distance between the vectors of SOLR and the vectors of Elasticsearch. It is almost a distance of one cosine of, so angle between the solar and Elasticsearch vectors is almost zero. So the most similar to SOLR is Elasticsearch, which is correct, right? I mean, those are the search engines which we were looking for in our initial queries, which I showed you. Similarly, most similar to YouTube is Vimeo. Both are online streaming applications. And again, if you see the vector between YouTube dimensions and Vimeo word dimensions is almost around one, which is the cosine distance is zero, right? And then we could use this to look for similar query or synonym expansion, like did the user look for SOLR, then we may want to suggest some Elasticsearch approaches for that, or vice versa. Like if you're searching for Elasticsearch, give suggestions for Splunk, give suggestions for Azure search, or difference between Elastic and Azure search, those kind of recommendations. So this is how, if the user is we did this to not exactly on the call reports, because that was a very potential text to have experimented on at a POC level. So this is something which we have already presented, and now we are in the process of actually ingesting our call report data and testing the word to vec machine learning on it. So let's say the user is typing declining DRAM, which means we will also give him downward trends for DRAM, decreasing capex for DRAM companies. Then we might also give him suggestions for DRAM companies which are doing not so well or expected to go down, something of that sort, and so that he can have a better a view of the call report text which he is searching, or even try to derive some trends from the past call reports that are already there in the repository. So if you go to the other industry cases of ELK and word2vec, Elasticsearch, as you know, is used in logging and log analysis. Word2vec is used in trend prediction and recommendation along with Elasticsearch, and also stock price trade analysis to help the customer with better financial investment advice. This is basically what our department is doing. We are analyzing call reports and then analyzing the trends to help the customer do better investments with us, right? And purpose of log mining, that is being leveraged on by Citibank, Credit Suisse, Barclays, right? For tracking malicious activities, hacking attempts, website visits and searches done on those websites, mining all those information. And again, if our trading department, how they uses online authentication failures, or we are using, our trading department is using the logs for anomalies generated in one particular trade and how to overcome those. So this is also used by leveraging on the Logstash and Kibana functionalities. And trend recommendation and prediction is being heavily used by YouTube, Facebook, Instagram. Also, if you look at the new Gmail, as soon as you start composing a mail, it will give you a sentence completion. What it is actually doing is it is looking at the context of the mail which was sent to you. So let's say you have a mail from someone, recruitment agency, which is asking you, are you free or not? and then if you start replying to that mail in Gmail, I'm sure many of us we know that it would immediately give you appropriate sentence completion. How does it do that? This is the exact application of word to vec. It knows the context of the mail which you are, replying to, and accordingly it will suggest you. So of course that is much more advanced than just using word to vec. It also uses a lot of cognitive services, natural language processing paradigms. But this is exactly a classic use case for word to vec, wherein depending on the context, it is going to predict or it is going to suggest you as appropriate sentence completion. Then again, ELK and Word2Vec are used in tandem on Twitter and other online apps, right? And this is the word cloud. So word cloud prediction also, we are using Word2Vec and Elasticsearch for a word cloud prediction. So as you see, the most trending word for whatever analysis we did was big data. So right now this is like the most trending word. And one case of Uber comes to mind. So forecasting rider demand. So they are also using, for this forecasting, they are also using, heavily relying on Elasticsearch and machine learning algorithms, right? And stock and trade price analysis. If you're very interested, you can go to the use cases which are highlighted on elastic.io, and these are one of the most leading players of financial and tech industry that are leveraging and doing a fantastic job of using the Elasticsearch tools. And well, that's it. So yeah, I would be happy to take any questions. Okay, so if there are any questions, you can just keep me posted on my on YouTube. And good day to all. Be safe.
Yeah, let me start. Is that okay? You all see my screen? Hi, I'm Eng Teong. Today I'll talk about managing technical debt with Azure DevOps. You can find me in my Twitter. And what is the source and the impact of the technical debt most in the IT industry? Maybe you not realize that technical debt is whatever people is not hand properly is one of the reason hands on properly to the next person. Because as a human, some of us will be forget. It's easier to forget. For example, I asked you last week what you eat. You also maybe you forget. Okay, let's start. The technical term is a term that describes the future penalty that you incur today by making easy or quick choice in software development practice. Rather than taking harder or longer choices, there are more appropriate longer terms. Over time, it occurs in mass in same way that monetary debt does. Common source of technical debt are lack of coding style and standard, lack of poor design and unit test case, ignoring or not understanding project-oriented design principle, monolithic classes, and code library. Great envision use of technology, architecture, and proof, forgetting that all attributes of system affecting maintenance, user experience, scalability, and others need to be considered. Over engineering code, adding or creating a code that is not needed, adding custom code when existing library are sufficient, or creating a layer or component that are not needed, insufficient command and documentation. This is most probably software houses do like you done first, then after that you're doing a documentation. Not writing a self-documenting code, including class method and variable names that are descriptive or indicate intent. Taking a shortcut to meet a deadline. And last, leaving a test code in place. But this will cause a lot of the consequences you need to think about as a problem during development that made it more difficult to add customer value. Yeah, if you have a lot of bugs, then customer will decrease the competency of your product. Sub productivity and frustrated development team. Yes, correct. Because you have a proper documentation, your developer also suffering. Then you need to keep continue asking. Third, make code both hard to understand and fragile. For example, you declare a name is called A. Then what is meaning of A? Fourth, increases the time to make changes and to available to those changes. Start small and grow over time. Over time, technical debt must be paid back. Otherwise, the team ability to fix issue and to implement a new features and enhancements will take longer and longer, and eventually become cost prohibitive. One way to minimize accumulations of the technical debt is using automated testing and measure technical debt. We have seen that technical debt as a set of problems during development and made it much more difficult to add additional customer value. Having a technical debt is in a project sub-productivity, frustrate development team, make code both hard to understand, fragile, increase the time and changes, and so on. Long term is also a sub-organization strengths technical debt create up on an organization. It start from small and grow over time. And a serious issue arise. Eventually, the organization cannot respond to its customer need in a timely and cost-efficient way. There are many tools that can be used as an aspect of your code quality and technical debt. NDepend. For .NET developer, a common tool is NDepend. NDepend is a Visual Studio extension that assesses the amount of technical debt that a developer has added during a recent development period, typically in the last hour. With this information, the developer might be able to make a required corrections before ever committing the code. NDepend let you create code rules that are expressed as C# LinQ query, but it has a large number of built-in rules that detect a wide range of a code smell. Second is a reshopper code quality analysis. Reshopper can make a code quality analysis from a command line and can be set to automatically fill build when code quality issues are found. Rules can be configured for enforcement across teams. And the third one is search in Azure DevOps to find other code quality tools that are easy to integrate with Azure DevOps. Search for the words quality when adding tasks into your build pipeline. Now I'm going to the demo. For this lab, you can refer to following URL to practice. Before that, I already deployed one of the project and run through a wall. For starting, you need to go to a new pipeline. Then you select a use case editor and select back and insert. You need to don't forget to add in the .NET Desktop Cloud, .NET Desktop SonarCloud. Then at the first thing, before that, you need to disable a publish quality gate result first. Because we not use this for this demo, but in the SonarCloud, you need to create an account and free and select free. You will get unique token for it. First, you come to prepare analysis on the SonarCloud, and you click on the new. Yes. Bye. I will message you. And you click on new. Then you put your SonarCloud token where to get it. Okay, let me do this one. Log in first. Go to my account, and security. Then you key in your generate token, and for example, my Azure DevOps, you will generate a token, then you paste into a SonarCloud token and click on verify. After that, you give a service connection name like a SonarCloud, then you verify and you select from the SonarCloud service endpoint. After that, you select organization. Then project key, you just key in your project name dot your name, and so on, like project names, advanced control options, and output. Then the others is you just put it by default. Then after that, you click on queue. Then you keep continue running. For my previous result is I will, after you get everything is done, and where you can check the SonarCloud result, you go to code analysis, then you scroll down until the end. Then you can go to you click on this URL, then you will see the project. Okay, this is my previously created. Then you will see the reliability, measurement, security, maintainability, coverage, how good of of your web applications. For example, your automatic detected you have 90 bugs. Reliability rating is still detected at least one critical bug. Okay. Then security. The most concern is the data leak about that. You will see everything and review reliability, maintainability. If get A, it means good. But if you get a D or E, for the different point of view, is a bit worse. For example, I go to this. You can go to see that one of the no-use code that they're not covered by test. No-use code, it means that you write a lot of non-related code into your applications. You see not covered by test. The test can't go through. Maybe this portion is not using in your error applications. Then after that, you solve, then you just automatically run again. Then you will see everything. And if you have any questions, please let me know that I can help you, I can answer. Is there any questions? Thank you very much.
All right. How is the sharing today? It comes to an end soon. So if you have any comments for us, please feel free to drop a message in our YouTube channel or our Meetup page. Hi Riza, welcome to our YouTube. So yeah. All right. However, before that, I have a few announcements to make. Next month, the Microsoft Ignite, the tour will be back to Singapore again, and the date will be on 20th of February, Thursday. It's a weekday. So the event actually brings the very best of Microsoft Ignite to Singapore. So it will provide technical training led by Microsoft experts. So if you would like to learn new ways to build solutions or migrate your existing infrastructure, manage them, and connect with our local leaders and peers, please join us. Oh yeah, I think our speakers tonight, Priyanka and Eng Teong, will be there as well to be the speakers. So remember to sign up and network with them. Hope to see you all there. And once again, I would like to thank our speaker as well as all of you from different places in the world. Thank you very much, and I hope you enjoy the session today. Together we learn better, and please start using Azure if you haven't. And see you next time. Bye bye.